consistent goal. So today's problem of the day is number of distinct islands. Basically, what we need to do in this problem, you are given a grid of n cross m, and what you need to do, you need to find the number of distinct islands. Now, exactly what do you mean by distinct islands? Suppose you can check this out here. This is an island, and this is an island. To be more clear, just consider this. In this case, let me mark it green color. This is one island, and this is another island. Now you need to find the number of distinct islands. So in this case, you can see this island, right? I consider this island. So this becomes one of our islands. And the another island which we are considering is this. But this island, this one, is exactly same as the island we chose before. So how many distinct islands we get? We get only one distinct island. Now consider the second example. We can consider one of the islands as this one and another island as, okay, sorry, this is the same example. Let me just bring the second one. So let's consider this, right? So this is the second example. Let me show it to you. Let's write it here. This is the second case. And let me just make all them in black color. And okay, so this is the second example. And let's just format this a little bit. Right. So here you can consider one of the islands as one of the island can be this one, right? So we can consider that one of the island is one, and a one here. Now another island can be considered as this one, right? So the next island can be this and this. So now we have two islands. The next island we can see in the matrix is this one. But hey, wait, this island is exactly the same as this one. So we will not consider this. Now we will check the next island. And this island is not same as the island we found before. So we can consider this island. So we have exactly three islands. And this will be the last. So we have the number of distinct islands as 3. And hence the answer for this example will be 3. Now how to approach this problem? So basically we need to just do 2 steps in this problem. The first step is to count the number, or I should say I need to break this problem into 2 sub-problems. First, I need to count the number of islands. And the second thing is I need to check distinct, that is, I need to consider only distinct islands. Now, how to do that? So, what we can do, as you can see, we need to consider only distinct island. That means, suppose in this case only, when we were considering this one, this island, and so we just considered this island, and then when we found a duplicate island same as this, we did not consider this. So when we hear the word duplicate and we want to avoid a best data structure that comes in our mind, that should be a set. Now set, but set of what? We can just consider this thing as, like this coordinate can be a 0, 0. This coordinate can be 0, 1, and this coordinate can be 1, 0, right? So can I say, if I consider these pairs as pairs of indices here, like this pair, and this pair, and this pair. These pairs will be same for any duplicate island. Now, if I consider this island or this island, my points will be 0, 0, and the next point will be 0, 1. In this grid, of course, these are not the coordinates, but if I need to consider this in our number of islands, then I'm saying to just store this like this in the form of pair of coordinates. Now, if you will consider this island, this will have exactly same coordinates as this. So can I say I have pair of these coordinates? So can I say we can use a data structure that is set, which is a vector of pair of integers, right? So we can use this data structure to solve this problem. Now let's see how we can implement our code. First of all, we need to just create two variables. That is the number of rows in our grid that can be like grid dot size, and the number of columns in our grid. That will be considering the columns of any of the rows of in the first row, and that will become our n. Now, as we discussed, we need a data structure. So I can just take set data structure, which will be storing vector of pair of integers. Right. Now, this becomes our data structure. And what should I name? This should contain a number of distinct islands. I'm naming this set as my islands. Now we need to iterate through the given grid. So for that, we can just iterate a loop on the grid, just like this. Now what we need to do for every element of the grid, first we need to check if that element is a 1, then only we need to consider it for DFS traverse. Otherwise, we should not be traversing it. So if we can select grid of I, j, that means if the grid I, j element is a 1, then we need to consider it for DFS traverse. What we will do, we can just create a vector of pair of integers, and then we need to just let's call, we will be storing our island, because since we found a work in our grid here, that means this can be considered as one of the islands. So we will be storing this complete the set of 4 ones in this one island. So I will be needing a vector of pairing to store this island, and then I will be inserting this island in the islands set. Right. So we will call our DFS function to store the complete island in this island. And how we will be doing that, I will show you just after we have completed this code. So we can just say we need to give it parameters, that is its current position, that is I, j, and this base point. So how are we going to store this island in our vector? Suppose we are having, let's say, this, let's consider this island. So we need to first consider a base point for any island that we are going to consider. The base point will be this one, the starting, which we occur in the traverse. This becomes our base. So let me just write it. This becomes our base. What do you mean? What do you mean by base? Base means 0, 0. And then we need to mark other points which are the part of this island relative to the base. So this becomes a 0, 1, and this becomes 1, 1, and this becomes 1, 0. So that's what we mean by base and relative marking according to the base. So first I'm passing the grid param, the I and j, which is the position of this island in the grid, that is the position of base in the grid. And then I'm also passing the this ij is the position of this point in the grid, and now I am passing the position of base for this complete island. This will be CMS I, j, because base is also one of the point. And then we need to pass N and M and the other parameters like grid and the island which we need to store, in which we are going to store our island. So that's all. Once this DFS call is complete, we just need to insert this island in our islands. So in our island set, we will just insert this island in our island set, and that's it. And what will be the number of distinct islands at the end? That will be the size of a set islands. So we can just return islands dot size as our answer. Now we need to complete this DFS function also. So now let's define our DFS function. Obviously, this will be a void function DFS, which should be considering the position x and y of the point in the grid and base point. That is, let's consider that as x naught and y naught. This will be the coordinate of the base point in the grid. And then we are having the parameters as n, then m, and then we are considering a parameter that is the actual grid. And we will be passing the grid by a reference because we need to also mark those ones which we have considered in the island as visit. So we will be marking those ones as zeros. So we do not traverse them again. And then we will need to pass our island because we are storing our island in this island vector. And we will be also passing this by reference because we will be editing it. And as we are going to add some and the points which are the part of the island. So in this DFS call, what we need to check at first. First condition should be that whatever these XY points are, they should be in the bounds of this matrix, in the given matrix. So first we need to just write a condition that if x is less than 0, that is if x is negative or x is greater or equals to n, or y is negative or y is greater or equals to m, that means this is out of the bounds of matrix and we will get a same condition for it. And hence we should return in these conditions. And then we need, since this we have what a DFS call for this point, that means this point has to be a 1 because we are only considering those points which we are 1, those base points. Now we need to complete the island from this. So this base point definitely needs to be a 1. So we will first mark this grid x, y, and 0 so that we do not traverse this again. Now we will just and yeah, we need to just push this point also. So we will just push this point. Island or push back a pair, and this pair will be x, y. In fact, x minus x naught and y minus y naught, because we want to push the island in our island such that we have absolute relative index by the base point, like this index. So we will just start from base, and if I consider this point or considering an island, then this will be whatever its coordinate are in the grid and minus the coordinate of base point. So we will be getting 0 as x coordinate and 1 as the y coordinate. Great. Now, after this thing is clear to you, we have pushed this point in our island. So now we need to consider the next points, the other points of this island. So what will be the other points? If I have this point, then I need to go to the right, left, top, and bottom directions. Great. So I can just say, if I need to go left, then if x minus 1 is greater or equals to 0, because I do not want to go out of the bound, I'm great. And this grade of x minus 1 comma y needs to be a 1, because if I'm suppose here and I'm going to the left direction, then it is a 0. I do not want to consider a 0. I only want the next other points of this island that needs to be a 1. So I need to put this condition and both of these. So, and that I need to make a DFS call to that point also. So that point will be x minus 1 and y, and the base point coordinates will remain x naught and y naught only, and then and the other parameters will remain as x. So that's it. We made a DFS call to this point. Now we need to do this for the other top, bottom, and right directions. Was this DFS call was for left direction, and now we need to make a DFS call for the, let's say, right direction first, and then for the other two directions. So we can just copy this code and we will edit this here. For right direction, this needs to be x plus 1 and it should be less than or equals to m. And this should be x plus 1 y, and this becomes x plus 1 and y, and other things remain same. Now let's move to the top. We will again just paste this code, and if we want to move to the top, we need to make it y minus 1 should be greater or equal to 0, and grid of x and y minus 1, and here it will be x and y minus 1. That's it for the top direction. Now we need to take care of the bottom direction also. So now we will just write this thing again, and now we need to check for bottom. So y plus 1 should be less than or equals to m, and it should be x and y plus 1, and now we need to mark here also x and y plus 1. Now we have checked for all on the after this DFS is complete. You know, when I call a DFS for the base point, this DFS should store all the points which are a part of this island, and then we have pushed that in our island set. And if there will be a duplicate island, then that will not be considered the set. And then we can just return the islands.size to get the distinct islands. Now let's try running this code and see if this is working. Okay, so there is an error. Yeah, so once we are getting island. Okay, so are we getting x, y, x naught, y naught? Okay, guys, so the problem was that in this function, we have just created the island as a vector of int, and it should be a vector of pair of int and int, and that should do our job. And now let's try to compile and run this code again. Now let's submit this code. And we have solved this problem successfully. And I hope you liked the explanation. And if you did so, make sure you hit the like button and subscribe to this channel. And I will see you tomorrow with the next problem of the day.